This is SpaceTime Series 22, Episode 38. Blue Origin reveals its new Blue Moon lunar lander. A dark matter detector observes the rarest event ever recorded. And the European Space Agency to launch its new Vega-C rocket before the end of the year. All that and more coming up on SpaceTime. The world's richest man, Amazon boss Jeff Bezos, and his Blue Origin aerospace company could have people walking on the moon by 2024. The 2024 date was proposed by the Trump administration earlier this year, after NASA had originally suggested a return of manned missions to the moon in 2028. Bezos says Blue Origin have already been working on a project to return people to the moon for over 3 years, and so will be ready to achieve the 2024 deadline set by the White House. The 55-year-old made the claim during the unveiling of Blue Origin's new Blue Moon lunar lander. Looking a bit like a beefed-up version of NASA's famous Apollo-era lunar excursion module, the LEM, the new four-legged Blue Moon lander will have a fully fueled mass of 15 tons and be capable of carrying 3.6 tons of cargo and supplies to the lunar surface. The vehicle will be capable of carrying scientific instruments, deploying satellites, releasing robotic lunar rovers onto the surface, and potentially future pressurized lunar vehicles for humans to drive around in. A taller stretched version carrying extra fuel will be capable of transporting up to 6.5 tons, including a lunar ascent module for manned missions to the lunar surface. Bezos wants Blue Moon to land near the moon's south pole, where deep craters with floors in permanent shadow hold vast deposits of frozen water ice. These deposits could be exploited to produce hydrogen and oxygen to fuel longer-distance deep space missions to Mars and beyond. The White House's 2024 deadline has put NASA into a spin, as neither their new heavy-lift rocket, the SLS, being built by Boeing, or their deep space capsule, Orion, being built by Lockheed Martin, are likely to be ready in time. US Vice President Mike Pence says if NASA can't meet the 5-year deadline, he'd be looking at the private sector to step up to the mark. And both Blue Origin and SpaceX have suggested the 2024 lunar deadline is feasible. Existing missions using SpaceX's Falcon 9 rockets and Dragon cargo ships are all running smoothly, and SpaceX has just conducted the first commercial launch of the world's most powerful rocket, the Falcon Heavy, and work on an even larger, more powerful rocket known as Starship is now gaining momentum. The Hawthorne, California-based company is also continuing to develop its Crew Dragon 2 capsule, which will eventually transport people to and from the International Space Station. However, an explosion which destroyed a Crew Dragon 2 capsule during a ground test at Cape Canaveral last month has now put that project behind schedule. The company is, however, still planning to send a Japanese space tourist and some of his friends on a journey around the moon in the next few years. That'll be aboard a Crew Dragon 2 capsule, while another Crew Dragon 2 capsule, this one on a robotic mission, will soon be sent to Mars under the guise of Red Dragon. Blue Origin, of course, is also working on 2 other projects beside Blue Moon. There's its New Shepard suborbital rocket to fly tourists to the edge of space. That's just scored another major success, with its 11th test flight meeting all parameters. New Shepard's now expecting to take its first people into space before the end of the year. And work's also continuing on the company's new heavy-lift rocket, New Glenn, which is expected to fly in 2021. As part of that project, Blue Origin's now taken over and started construction on the site of the former Space Launch Complex 36 at the Cape Canaveral Air Force Station. Bezos sees New Glenn as the key to future space exploration.
We're going to build a road to space, and then amazing things will happen. There are certain gates we have to go through, certain precursors, certain prerequisites. If we don't do these, we will never get there. First, we must have a radical reduction in launch cost. Launches are just simply too expensive today. And second, we have to use in-space resources. Earth has a very powerful gravitational field, and lifting all of our resources off of Earth just isn't going to work. We need to be able to use the resources that are already in space. Here's New Shepard. The Blue Origin team has already made amazing progress on reusable launch vehicles. Almost no refurbishment between flights. That's how you reduce launch cost. You have to have reusable vehicles. Today, what we do is we use launch vehicles one time and throw them away. You also can't have, kind of fake reusability where you bring the vehicle back, but then do a lot of refurbishment. That also turns out to be very expensive. We're going to be flying humans here in New Shepard this year. That's incredibly exciting. New Shepard is a suborbital vehicle designed for space tourism. And we made, for that mission, some very curious technology decisions. First of all, New Shepard is powered by liquid hydrogen. It is the highest performing rocket fuel, but it's also the most difficult to work with. And it's not needed for a suborbital mission. So why did we choose it? Because we knew we were going to need it for the next stage, and we wanted to get practice with that hardest to use, but highest performing propellant. Same thing with vertical landing. Why did we choose vertical landing for New Shepard? It's very counterintuitive, actually. There are other landing mechanisms that would have worked at this scale. In fact, vertical landing gets easier the bigger the vehicle. Vertical landing is like balancing a broom on your fingertip. You can balance a broom, but try balancing a pencil. It's very challenging. The moment of inertia of the pencil is too small. So the great thing about vertical landing is it scales up really well. The bigger the vehicle, the easier it is. And right from the start, we wanted to build a human-rated system so that we would be forced to think clearly about safety, reliability, escape systems, all the things that we knew we would need to have practice with in order to build our next generation of vehicle. Let's talk about New Glenn. New Glenn is New Shepard's big brother. New Glenn is big enough that New Shepard will fit in the payload bay of New Glenn. It's 3.9 million pounds of thrust. It's a very large vehicle. It's powered by liquefied natural gas as the fuel, very inexpensive. Big strakes on the end, that's to help the booster fly back to the landing ship. The second stage, it's powered by 2 of our BE-3U engines. It's the same engine that's in New Shepard. The same liquid hydrogen engine in New Shepard, but an upper stage variant of it. And we'll deploy the payload. The first stage is designed to be reused 25 times. It has a 7-meter fairing, which is very large. And that's important because a lot of payloads end up being volume constrained rather than mass constrained. It's a big vehicle. It'll lift 45 metric tons to LEO and 13 metric tons to GTO, to geosynchronous transfer orbit. And it's designed for human rating right from the very beginning. We'll fly it in 2021 for the first time. The second gate that I know we must go through, in-space resources. We have to use them. And we have a gift. We were given a gift, this nearby body called the moon. It takes 24 times less energy to lift a pound off the moon than it does to lift a pound off the Earth. Let me show you something. This is Blue Moon. We've been working on this lander for 3 years. It's a very large lander. It'll soft land in precise way, 3.6 metric tons onto the lunar surface. The stretch tank variant of it will soft land 6.5 metric tons onto the lunar surface. The deck is designed to be a very simple interface so that a great variety of payloads can be placed onto the top deck and secured. And the davit system, which is inspired by naval systems, is what's used to lower things off of the deck onto the surface of the moon. And the davits can be customized for the particular payloads. We have here as an example a very large rover. And by the way, even though that's a large rover, this vehicle can land 4 of them simultaneously on the surface of the moon. And if you go ahead and go back up on the deck again, let me show you a couple more things up there. On the left-hand side, you can see our star tracker, so that this vehicle can autonomously navigate in space. On the right-hand side, an optical communication system that gives us gigabit bandwidth back to Earth. It's a laser that transmits data back to Earth. We also have X-band for 10 megabit radio. Why are we using liquid hydrogen? This is not how Apollo did it. One, it's very high performance, and so that helps a lot when you're landing on the moon. That's that after you've got to carry all of your propellant to the moon. Second reason we're using liquid hydrogen is because ultimately we're going to be able to get hydrogen from that water on the moon and be able to refuel these vehicles on the surface of the moon and use them. So liquid hydrogen is an excellent choice for fuel for the moon. Landing gear, they're designed, the very wide splay angle is designed so that we can land on an incline on the moon of up to 15 degrees, which is a very big incline, be able to do that safely. We have flash LiDAR, so we can do terrain mapping. There's no GPS on the moon. So if you want to land precisely, and we can land within 75 feet of our target, when you want to land precisely, what you do is you use features on the moon to navigate. This is the BE-7 engine. It's liquid hydrogen, liquid oxygen. We're going to hot fire it for the first time this summer, which is the only reason we can do that is because we've been working on it for 3 years. Most of it is printed. It has 10,000 pounds of thrust, and it has very deep throttling capability. That's critical for a lunar descent engine because this lander, when it's fully loaded with fuel, weighs 33,000 pounds. When it's done its descent burn and it's just about to land, the fuel is almost gone. It weighs less than 7,000 pounds. And so to provide the right amount of force on the vehicle with the engine, you need to be able to throttle it way down as the vehicle is getting lighter because it's burning its own fuel. Vice President Pence just recently said It's the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years. And we can help meet that timeline, but only because we started 3 years ago. It's time to go back to the moon, this time to stay.
That's Amazon boss Jeff Bezos unveiling his new Blue Moon lunar lander. And this is SpaceTime. I'm Stuart Gary. How does one observe a process that takes more than 1 trillion times longer than the age of the universe? Well, the XENON Collaboration research team did it with an instrument built to find the most elusive particle in the universe, dark matter. A report in the journal Nature claims scientists observed the radioactive decay of xenon 124, which has a half-life 1 trillion times longer than the age of the universe. The detection was made using a 1,300 kilogram vat of super pure liquid xenon, shielded from cosmic rays in a cryostat submerged in water 1,500 meters beneath the Gran Sasso Mountains of Italy. Physicists say the observation shows this detector can measure the rarest thing ever recorded. The detector was designed to hunt for dark matter by recording tiny flashes of light created when particles interact with xenon inside the machine. Of course, dark matter is one of the biggest mysteries in science today. Scientists have no idea what it is, even though it makes up some 85% of all the matter in the universe. It seems to be this invisible substance which interacts only gravitationally with baryonic or normal matter, the stuff stars, planets, asteroids, houses, cars, trees, dogs, cats, and people are made of. Astronomers only know dark matter exists because they can see its gravitational effect on normal matter, such as preventing galaxies from flying apart as they rotate. Hypothetical subatomic particles such as axions, sterile neutrinos, and possibly primordial black holes are among the most popular current ideas to try and explain dark matter. Scientists have been using underground observatories like Gran Sasso, as well as detailed studies of objects in the halos of galaxies and experiments at the world's largest particle accelerators to try and uncover the secrets of dark matter. And while Gran Sasso was built to capture the interaction between a dark matter particle and the nucleus of a xenon atom, the detector actually picks up signals from any interactions with xenon. And that's where our story begins. The evidence for xenon decay was produced as a proton inside the nucleus of a xenon atom converted into a neutron. In most elements subject to decay, that happens when one electron is pulled into the nucleus. But a proton in a xenon atom needs to absorb 2 electrons to convert into a neutron, an event called double electron capture. And double electron capture can only happen when 2 of the electrons are right next to the nucleus at just the right time. When this incredibly rare event happened, and a double electron capture occurred inside the detector, instruments picked up the signals of the electrons in the atoms rearranging to fill the 2 that were absorbed into the nucleus. Electrons in double capture are removed from the innermost shell around the nucleus, and that creates room in the shell. The remaining electrons collapse to the ground state, which is what the detector then observed. It's the first time scientists have measured the half-life of a xenon isotope based on a direct observation of its radioactive decay. The detection, therefore, helps science advance the frontiers of knowledge about the most fundamental characteristics of matter. I'm Stuart Gary. This is SpaceTime. The European Space Agency is expected to launch an upgraded version of its Vega rocket before the end of the year. The new rocket, to be called the Vega-C, will use the more powerful P120 solid rocket motor for its first stage. The bigger booster will increase payload capacity from the existing 1.5 tons up to 2.2 tons to a 700-kilometre high orbit, with no increase in launch costs. The key is the Vega-C's new P120 first stage. It's the largest single-segment carbon fibre solid propellant rocket motor ever built. The engine was successfully tested back in July last year. Its development relies on new technologies derived from Vega's current first stage, the P80 motor. And the new engine won't be just confined to the Vega. Between 2 and 4 P120Cs will also be used as lift-off boosters on the European Space Agency's new Ariane 6 launcher, which will eventually replace the current Ariane 5 as Europe's heavy lift booster. The new Vega-C will also be capable of using a new larger 3.3-metre diameter payload fairing, allowing it to accommodate larger payloads such as Earth observation satellites and the agency's new Space Rider re-entry vehicle. The Vega launch pad and mobile gantry at the Kourou Space Centre in French Guiana are now being modified to accommodate the new Vega-C alongside the existing Vega rocket launch system. This report from ESA TV.
This is the Avio factory in Colleferro, Italy. This is where the carbon fibre casing for the first, second and third stages of Vega, and also of the future Vega-C, are developed. To build them, 5,000 kilometres of carbon fibre, impregnated with epoxy resin, is wound around a pre-made metal mandrel. This produces the very lightweight but sturdy casings for the first, second and third stages of the Vega launcher. These cases are later fitted with an engine and loaded with the solid propulsion. One of these solid propulsion engines is the P120C. It was recently successfully tested in Kourou. It is the largest and most powerful monolithic solid propulsion motor ever built. With Vega-C, ESA hopes to respond to launcher market demands.
So certainly in the launcher sector, the competition is growing worldwide. But we believe that the European answer, the ESA answer with Vega-C and Ariane 6 is the right answer. In an aggressive manner, we are trying to make things more and more competitive. One of these examples is the joint solid rocket motor that we are developing across the two programs, the Vega-C and the Ariane 6, the P120C solid rocket motor, that enables the possibility to harmonize resources and to have the same motor serving the Vega-C as a first stage as well as the Ariane 6 in both configuration as a strap-on boosters. So this is a very good answer to tackle the competitiveness aspect.
Thus, with Vega-C, the C standing for consolidation, ESA is further developing Vega. It will add an increased performance to the flexibility of the current system without increasing the costs. Today, Vega can launch up to 1.5 tons on a 700-kilometre orbit. With Vega-C, this will be 2.3 tons. In order to increase the performances, two new solid propulsion engines have been developed, the P120C, but also the Zefiro 40 for the second stage. Further enhancements are made with Avom Plus, which is derived from the current Vega's Avom upper stage. It will be lighter and have a larger fairing for bigger payloads. These changes also have implications for the Vega launch pad in Kourou.
We've foreseen a lot of activities to modify the launch site from the Vega configuration to the Vega-C configuration. Vega-C is a heavy, larger and launchers with respect to the Vega one. So, for this reason, we have to modify the hatches to the stages, increasing the diameters for what concerns the first stage.
Other changes include modified fluid services and the installation of a more powerful crane needed to lift the heavier second stage of Vega-C. During these modifications, the site has to remain operational for the scheduled Vega launches. In the end, the launch site will be compatible with both launchers. With Vega-C, ESA is also working on related products, such as the Space Rider, based on ESA Experimental Re-entry Vehicle IXV. It should allow for payloads to be sent into orbit and later returned to Earth.
In addition to this, we have other products like the specific adapter for launching into orbit small spacecraft, so enabling the possibility of universities and research centers to access space at limited cost, so coping with the payloads which go from 1 kilogram up to 500 kilograms. We also have early elements of definition for a platform called Venus, which could allow payloads to transfer from orbit to orbit.
And that report from ESA TV featured Vega site manager for Avio, Antonio Pizzacarelli, and ESA's Vega development program manager, Giorgio Tumino. This is SpaceTime. I'm Stuart Gary. Italy's new PRISMA Earth observation satellite has been successfully launched into orbit. The flight aboard a Vega rocket blasted off from the European Space Agency's Kourou Spaceport in French Guiana.
À tout de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80, décollage de V14 PRISMA. Propulsion nominale.
And they are off. PRISMA has started its journey. Vega blazing a trail across the night sky here in the skies over the Guiana Space Center. The Vega launcher takes its name from the brightest star in the constellation of Lyra, fifth brightest star in the night sky, and tonight she is lighting up our night sky. Heading north now over the Atlantic.
Séparation P80.
The separation there of the first stage.
Allumage Z23.
And he's telling us that the second stage is switching on.
Ariane Space Flight VV-14 deployed PRISMA into a 614-kilometre high sun-synchronous orbit 54 minutes after launch, following 2 burns of Vega's upper stage engine. After releasing its payload, Vega's upper stage undertook one final engine burn to ensure direct re-entry and burn-up in Earth's atmosphere over the ocean. It's all part of ESA's program to reduce the amount of space junk orbiting the Earth. Built by OBH in Italy, the 879-kilogram PRISMA spacecraft will spend the next 5 years monitoring the planet's environment and how that environment is being affected by the worsening impact of global warming. PRISMA will focus on resource management, crop classification, and pollution control. The probe carries an innovative electro-optical instrumentation package combining a hyperspectral sensor with a medium-resolution panchromatic camera. The hyperspectral data it achieves will assist scientists in forest analysis, precision agriculture, the monitoring of both inland and coastal waters, as well as climate change, environmental research, material exploration, and mining. The 30-metre-tall Vega is a 4-stage launch vehicle designed to carry small scientific payloads of between 300 and 2,500 kilograms, depending on orbit. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found only 37% of the world's longest rivers remain free-flowing, with dams, reservoirs and other human influences disrupting river connectivity and impacting ecosystems such as floodplains. The findings, reported in the journal Nature, have determined that only 21 of the world's 91 rivers longer than 1,000 kilometres, which originally flowed into the ocean, still retain a direct connection from source to sea. The study found that large contiguous river networks with intact natural connectivity remain only in remote regions of the Arctic, in the Amazon basin, and to a lesser degree in the Congo basin. In Australia, the dominant pressure on free-flowing rivers is fragmentation by infrastructure, such as hydropower and irrigation dams, and flow regulation through water storage. Changes to the Great Barrier Reef are becoming visible from space, a fact that Australian and international researchers are now using to monitor the reef's health. Using remote underwater cameras and satellite images from Google Earth, researchers looked at fish's grazing halos, plant patterns that show where fish have been eating, in order to estimate the health of the sea's life. They found changes in algae occurring over long periods of time in excess of 40 years and over thousands of kilometres. A report in the Journal of the Proceedings of the Royal Society B claims this approach can be used to detect and predict changes in reef ecology worldwide, and since it can be done using Google Earth, even inaccessible reefs can be monitored. New research suggests that whole-body scans of people with newly diagnosed cancers may end up being a quicker and cheaper way of detecting cancer that's spread. The findings, reported in the Lancet Medical Journal, are based on results from a trial which determined that for people with newly diagnosed bowel and lung cancers, whole-body MRIs could reduce the amount of time it takes to diagnose the stage of cancer by 5 and 6 days, respectively. Researchers found the results were just as accurate as traditional investigations such as CT scans, but the costs were substantially less. A small metre-high new relative of the famous Tyrannosaurus rex has been discovered in New Mexico. The fossils from 2 juvenile skeletons dating back around 92 million years provide fresh insights into the little-understood origins of T-Rex and its closely related cousins. Named Saskittyranus hazeli after the local Zuni word for coyote, the dinosaurs were each only about as long as a T-Rex's skull. Interestingly, these fossils were originally discovered more than 20 years ago, but it's taken this long to work out exactly what they were. Paleontologists say this new theropod dinosaur fills the gap between the smaller species of Tyrannosauroid, which diverged early on, and the giants that were to follow, such as T-Rex. Astronauts on long space missions can experience changes in their eyes and vision which can last for years, but now researchers believe they may have found a way to help them using swimming goggles. A study reported in the Journal of the American Medical Association examined 20 men who completed exercises while on their back to simulate the effects of exercise in space, with 10 of the participants wearing swimming goggles during their workout. The team found exercise decreases pressure on the eye, while the addition of the swimming goggles increased the pressure, which could reduce some of the adverse effects on the eye of long-duration space flights. Since the world went plastic crazy back in the 1950s, an awful lot of plastics ended up in the sea. Now, researchers have shown the rise in plastic pollution in the North Atlantic Ocean based on records spanning almost 60 years from a marine sampling instrument. A report in the journal Nature Communications shows that data from the Continuous Plankton Recorder, which has been towed nearly 6.5 million nautical miles since 1957, found a significant increase in plastics in the North Atlantic and surrounding seas since the 1990s, with plastic entanglement increasing by 10 times since the year 2000 onwards. Well, in a world full of people who are prepared to believe in flat earths and anti-vaxxing, it's hardly surprising that a new survey has found people are becoming increasingly sceptical of science. 3M's 2019 State of Science Index has found that some 35% of people are now sceptical of science. That's an increase of 3% over last year. Tim Mendham from Australian Skeptics says the study also shows that more than a quarter of people are suspicious of the role of science over the next 20 years. And in the United States, that number's even worse, at a third of all people.
It's a survey done by the 3M company, which is a company that makes post-it notes, sticky tape, that sort of stuff, although they make a lot of other products as well. Very large organisation do a very large survey on thousands of people across a whole range of different countries, but across a whole range of different things, asking people what their view is of science. Are they frightened of science? Do they think science is helping them? The latest survey indicates that there is a slight increase in cynicism towards science, that people are less confident. I mean, but there are areas in which people feel highly confident of scientific activity, and those tend to be the areas that they deal with all the time. When they are confronted with scientific achievements in their area or an area of interest or one that impacts on them, they are very supportive of science. It's those areas that they have trouble understanding or don't understand at all or don't make the effort where they have their doubts. Now, for instance, in the health area, people are highly supportive of medical science because they know it works and it helps people by and large. In areas of physics, they get a bit confused because it's a bit difficult because it's hard to understand. If they get into climate change, it's very hard to understand, and people sort of worry about it because doubt is spread by ignorance. And I use that term ignorance not necessarily in the pejorative sense, but lack of knowledge encourages doubt. And I think the whole solution is to educate people about these things, as people are in medical areas, because it affects them. When it doesn't affect them, when it's an abstract, they doubt it. When it does affect them, they are very supportive. Or in an area which has a high interest level innately, people are very supportive of space science, your area, right? Because it's interesting and exciting and the unknown and it's epic. People are also very interested in dinosaurs. So there's three areas of science which virtually everyone's interested in: space, medicine, and dinosaurs, and they have a high positive rating. If you're talking about other areas which they feel they don't know about, and because they don't know about it, they see it as a threat, they have a low positive reaction to it. So it comes down to education as much as anything.
If they're sceptical about it, is that the Dunning-Kruger effect in action?
I don't think it's as confident as Dunning-Kruger, which says that what you don't know, you think you do know. You're an expert on it. The less you know, the more confident you are, and the more you know, the less confident you are.
The reason I mention that is because if I'm discussing a scientific topic about an issue I have no knowledge of, rather than be skeptical about what the expert's saying to me, the scientist is saying, I'm more likely to be willing to accept what they're saying because they know more about that topic than I do.
Not everyone's as scientifically minded as you are, Stuart. Is that basically most people, when they see something they don't understand, they put up a blockage. It's a fear factor comes in. I don't understand it, and that implies to other nations, other people, other cultures, and areas like that, because they basically put up a barrier, and the barrier becomes a bias, and it becomes prejudice, and it becomes cynicism.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary. At Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.